All right, welcome everyone. This is Builders Day, Dublin. I hope everyone's in the right place, at least in the right city. My name is Brent Langston. I'm a developer advocate. By the way, when I back up like this, can you still hear me? Oh, all right, that's pretty impressive. I'm used to moving around when I walk, so I'll just be moving around, in these 2 feet right here. I'm Brent Langston. I'm a developer advocate on the containers team, and I'm here to talk to you about containers and why AWS is the best place to run your container applications. I want to start off by just talking about what are the options for running containers on AWS. So this session is just going over at a high level what's available to you on AWS. And then throughout the day, we'll sort of deep dive into each of these topics. So let's start by defining what is a container and why are customers using them. Raise your hand, are you using containers today? Awesome, most of the room. How about, are you running containers in production today? Less, but still maybe half the room. How about, are you orchestrating containers today with a high-level orchestrator like Mesos, Kubernetes, ECS, or some Docker Swarm? All right, fewer still. That's very cool. So what that tells me is everyone has found some value in using containers, and most of the room raised their hand. Half of you, about half the room or so, raise their hand for running containers in production. So they see enough value that they're able to get their workloads pushed all the way through the development cycle and out into production. And then less of you are actually orchestrating and taking full value of being able to rapidly spin up and spin down containers. So hopefully by the end of the day, you'll have a good picture of why that's useful and how to get there. For those of you that didn't raise your hand on any of it, that's okay. You're still in the right place. What is a container? It's an atomic, self-contained package of software that includes everything it needs to run code. Code, runtime, libraries, packages, etc. So basically, when you want to distribute software, when you need to deploy the next version of your application, think about all the work that goes into it on a server, for building a server. You have to, of course, install and configure the operating system. But then after that, you have like all of your shared libraries, all of your upstream dependencies that your application needs. So if your developer, added a gem or added a pip or added you name it to their application, you would have to have that on the server. So historically, developers would do that, and then there's the pitch it over the wall problem of operations where the developer just hands an operations team their code, and they say, make it work. I forgot what I did. I forgot everything that I've done over the past few weeks, over the past sprint, to make this application work. So the operations person has to sit there and figure out, they installed this library or they added this dependency and it's not in a list anywhere. So there are many ways to combat this problem, and containers is one of them. So with a container, the developer can actually add the library or the application to the build. And they can see, from 0 to completely built and running, this container works on my laptop. And then they can hand that container off, or at least hand the description of the container off to their person, their operations person, and that person can just build it. And it should build flawlessly. And it should run exactly the same way that it ran on the developer's laptop. So that was the original sort of problem that Docker was trying to solve. Make it simple for developers to describe to everyone else how to build this application, how to package it up, and how to ship it. They also built tooling around pushing containers around. So you can very easily push an image, an artifact to a registry, and then you can very easily pull that artifact down from the registry. So they, in a way, were solving two separate problems very elegantly. They were able to solve building code and then shipping and deploying code. So, Docker, thank you. That was really awesome of you. And the community has built upon Docker a lot of additional tooling that we'll be looking at throughout the day. So before Docker, you could do this with VMs. How many of you deploy today, or at least remember a time when you deployed, let's say in Amazon, by building an AMI with your code baked into it and then spinning it up? Don't be embarrassed to raise your hand. It's okay. I've done it. So this is kind of the same idea. Take the code, take the build process, automate it, bake it into an AMI, and then deploy that new AMI. The problem with this is it's very heavyweight. It takes a long time. It takes many minutes to, even once it's fully automated, it takes very many minutes to build the AMI and then to rotate out all your infrastructure or bring up all new infrastructure and then kill off all old infrastructure. Your deploy times, might approach an hour, best case scenario, sometimes even longer. So it's something that, while yes, it's great to have that mechanism, it was better than nothing. But we can improve on it, and Docker came along and they took those same concepts of being able to very easily move a single artifact around, and they applied it to shipping code, and we're now able to iterate our versions very quickly in a matter of seconds to minutes. So the way that happens is, rather than shipping around a whole VM that includes a whole operating system, we can actually just ship around a Docker image that just includes what we need to execute our code. Just the libraries, just the application, and nothing else. So a side effect of this is the host operating system. Now that we're baking in all of our needs into a Docker image, the host operating system can become very simple again. So in the old days, you used to have to be very thoughtful, very mindful of how you configured your host operating system. And you would use config managers to make sure that it was repeatable. So you would have Chef, Puppet, Ansible. They would come along and they would configure whatever is necessary in that host operating system. Today, the only thing you need in the host operating system is a kernel and the Docker daemon. Maybe an agent for communicating to your orchestrator, and that's it. So once you have those things, you can run Docker applications. And once you can run Docker applications, if your entire suite of microservices is in Docker, you have everything you need. So that's the movement that the industry is moving towards. Dockerizing everything, deploying everything via Docker, and then you can very rapidly iterate on just the parts that you're working on. So I kind of have gone over some of this already. Why are containers so popular? They're portable. They can run on a laptop. They can run on a server. As long as you're staying within the very high-level kernel family, you can run a Docker image pretty much anywhere. So Linux containers won't really run on Windows directly, and Windows containers won't really run on Linux directly. But other than that, you can run Linux containers on Mac. You can build a container using Mac OS and then ship it over to a Linux operating system, no big deal. They're lightweight, they're easy to push around, they're easy to upload and download, they're standardized. So because of this standard, we can take the time to build tooling around testing and deployment, and then we know that no matter what the language is inside, we'll be able to use our tooling to deploy and have a good test pipeline and deploy pipeline. So that has encouraged experimentation. they're easy to deploy, and then of course this monolith to microservices thing. This movement started before Docker, but the problem was there were some barriers to it. You had to have so many more servers because every service ran on a server, and you had to configure each server a different way depending on what service was going to run on it. And now with containers, we can stuff a bunch of containers onto fewer servers, and we can have more density. So this has sort of accelerated the monolith to microservices story. So historically, the way things have gone, first customers ran Docker on EC2, and some of you indicated you're still here, and that's cool. So EC2 and Docker, it's great. This is definitely a step in the right direction. But we're hearing from our customers, make this easier for us. And you're going to detect a theme in this talk, make this easier for us, is something we listen for from our customers. And when we start hearing, the same idea from many customers, or at least the same pain point from many customers, we go off and we figure out, how can we make this easier? So for us, we came up with Elastic Container Service, or ECS. ECS, we looked at what customers were doing and what customers wanted to be able to do, and we thought, we could come up with an easy way to make this happen. So we wanted to make it easy to build and scale applications, deploy applications, and control where they're running. So managing the fleet of servers that the applications would run on was the difficult part. It was the pain point that we were trying to solve. Many customers were trying to do this using Chef or Puppet, and they were still stuck in that mode of having a description of a server that needed to run a select few containers, and then anytime they needed to adjust sizing, they would have to do it on a server by server basis. Well, when ECS came along, lots of animation here. When ECS came along, we were able to make the fleet of servers generic. It's just a big pool of resources at this point, and we can deploy containers anywhere out onto that pool. And you no longer have to think in terms of scaling instance by instance. You can just add and remove your applications as needed, and then occasionally, if you hit the wall on how big the pool of resources is, you just add more to the pool, right? That's when you get to scale up or scale down the instances. So it becomes a lot easier to, add or remove instances. So, excuse me, we were trying to remove the pain points and heavy lifting of scheduling tasks. So instead of scheduling on an instance by instance basis, now you can just schedule out onto the pool. Placement. You no longer have to worry about, I'm going to build a web tier, a front end tier, a cache tier, a whatever tier, and have all of those instances to manage, maintain, scale, reboot, etc. You just have a fleet of instances and you launch those applications. Oh, and my favorite, management control plane updates. So this is actually referring to, think about the control, well, we'll get into it, but the control plane of your orchestrator. We also wanted it to be easy for you to not have to worry about running it, operating it, updating it, etc. So we wanted that to just be automatic and you never have to worry about it. So if you take a look at ECS today, by the way, raise your hand if you're running ECS today. Nice, several hands. Anyone just shout out, what version of ECS are you running? The latest? Usually I get silence. I'm happy that you're creative enough to have an answer. Yeah, so it's a trick question. There are no versions in ECS. So you're always running the latest, right answer. We upgrade things in the background. We're constantly improving it. And you never have to worry about it. You just get those changes automatically. So I think that's really cool, especially if you've ever compared it to some of the other orchestration choices that are out there. I personally think orchestrating containers is the way to go. And I would pick any orchestrator over none. But at the same time, there are, within the selection of orchestrators, there are some that are easier than others. And ECS is among the easiest, mainly because you never have to worry about updating it. You never have to rotate to the next version or anything like that. It's really cool. So it's a managed platform, and it gives us a way to manage a fleet of servers, cluster management. It also gives us a way to deploy containers, so we can just schedule on a container by container basis or on a service by service basis. And then it has deep integration into other AWS services, and we'll talk more about that in a little bit. A lot of customers are actually using ECS, and they're using it on a very large scale. ECS is one of the most scalable orchestrators available to customers. If you think about all of the orchestrators that you have that you can choose, at some point you'll hit an upper limit where you can't add any more nodes, or you can't churn containers any faster than you already are. And that limit for some customers might sound pretty high, but it's very approachable for almost any customer. With ECS, we run a managed control plane for every customer in the region. So one control plane, multi-tenant for every customer. So you can imagine that we have hundreds of thousands of instances under management, and we're launching millions of containers all the time. So it's really impressive that we're handing over a control plane that is this scalable and giving you basically no boundaries to be able to launch, experiment, and run your applications. GoPro. By taking advantage of Amazon ECS, we have the power to understand, manipulate, and manage our environment easily. So they are constantly experimenting and launching applications out onto ECS, and then routing a little bit of traffic to it and seeing how is it working? Is it slow? Is it fast? Am I getting a lot of errors? Am I not? And then if they need to, they can roll it back. Or they can iterate and continue to roll it forward. They were able to achieve a 70% reduction in their compute footprint. So they were able to reduce their instances by 70%. Think about that for a second. Instead of running an instance or a set of instances or a fleet of instances per service, they can now combine everything into one big pool and run in a much more dense fashion and have fewer instances that they have to worry about paying for. So I mentioned we're constantly improving, constantly adding to ECS, and you just get those changes automatically. What have we added in 2018? Faster launch times. We've improved launch time for ECS. I'm not sure what the statistic is, but faster is always better, right? Task metric and metadata endpoint. This can be used to establish insight into where your container is running. Your container might want to know where it's running so that it can have an understanding of the best option for it to, for example, talk to its backend or talk to another container. So we have a metadata endpoint that allows you to discover that kind of information. Route 53 auto naming. As your containers come up and down, it's nice to be able to locate them sometimes, especially when it comes to horizontal traffic, container to container traffic. That kind of traffic you can do directly instead of going over a load balancer if you can know where the other container is running. We updated Docker to 1709, so you now have a pretty modern Docker engine. And then we allowed config options, SHM size and tempfs. There's actually a bigger list of options we've added to since then, but you see the idea. We're constantly adding Docker options to the task definition so that you can add them yourself. Daemon scheduling. This was a big one. Customers were asking for this because sometimes there's a workload that you need to launch, and the way you want to schedule it isn't based on any kind of scaling metric or any kind of capacity. It's actually based on number of instances you have. An example of this is a log driver or the Datadog agent. So if you need to deploy, one per server, that's now completely doable using daemon scheduling. This was something that before we launched this, you would have to, be sort of constantly on the lookout of how many instances do I have in my autoscale group, and then you would adjust the deployment accordingly. And there were no guarantees about, would your container that you're trying to deploy make it onto every instance, because some instances might be full. They might be full of other services. So with the daemon scheduler in place, we're actually able to, as you add or remove instances, adjust the number of this type of container that we expect to be deployed, and those will be deployed onto every machine. CLI support for Docker Compose v3. Some shops will actually have a local Docker Compose environment for their developers. So their developers, if they need to bring up all the services to test against on their laptop, they'll use Docker Compose up. And that's cool, but then what if you want to translate that into deploying out onto ECS? So we've always been able to translate a Docker Compose file, but we were locked down to, I think, V2. I don't remember the version specifically. But we've updated now to V3, so you can Docker Compose locally, and then you can use that Docker Compose file to get you started out on ECS. Docker Container health checks was another big one. One of the cool things about Docker is, one of the cool things about Docker is you have health checking built into it. So rather than worrying about, am I listening on an HTTP port? Is that port always available? Yeah, that's a great health check, but not everything that's running in Docker is an HTTP process. Sometimes it's a worker process that's just processing something, or sometimes it's listening on, a UDP port, or it's listening on, something else that's not HTTP protocol. So having your load balancer reach out and check is certainly still available, and that was the starting point. But now you can define a check right in the Docker file, and then we can honor that by looking and seeing, hey, this container is healthy, or if it's not healthy, we can kill it and bring up a new one. We started signing the ECS agent to add reassurance that you're running the correct agent that's unmodified. And then we built in SSM parameter support. This is one of my favorites because secrets management and parameter management is sort of a difficult to solve problem. Only now it's simple. How many of you guys use SSM today? This is very few hands, by the way, went up. This is a little known service that everyone needs to be aware of and start using. It's just a simple key value store that you can write into, and you can encrypt using KSM. And then you can, using IAM roles, assign privileges that allow pulling of these keys and values. So by having this, you can put encrypted secrets into SSM, and then you can pull them out. So like, for example, a database password. The database username and password is something that you very often need to provide to an API server. The way that you do that, there are many ways to do it, but one way customers do it is by writing that or injecting it into their container environment. So we've basically built integration that'll do that for you. So you just define in the task definition, these are the keys that I need to know, and it will reach out to SSM as the container starts up and read in those values and add them into the container environment for you. And then service discovery. I mentioned horizontal container traffic. Service discovery is sort of the higher level version of that. So we built on Route 53 auto-naming the ability to basically use Route 53 and have a DNS-based service discovery. So now if you have a container that's named cache or something like that, and you need to be able to reach it from some other container, you can just DNS resolve cache.local and go, send your traffic directly to that container. Since it's built on Route 53, Route 53 is an extremely reliable DNS service, and the domains are all local and internal only to the VPC. So this is traffic that'll just stay in the VPC and only resolve inside the VPC that way. We also run ECR. This is another, to me, great service that solved a huge problem, but it didn't actually feel like it was a huge problem, I think because it came along so early with the solution. Has anyone ever run their own registry? I did. It was awesome until one day when it wasn't. I fired up the registry and I had it writing to S3 and everything was great. And I thought, well, gosh, this is easy. Everything is configurable in the environment. All I need to do if I need to change something is change an environment variable and redeploy. All my images stay in S3. It's perfect. Why would I do anything different? And then as I started scaling, I started noticing that container pull times were much slower. And I was like, what's going on? And I realized, oh, I need to add caching. And so there's a way to cache using Redis. So now I'm running a fleet of Redis servers that, a Redis cluster. And I start looking at it and I'm thinking, why am I doing this? I have, capacity for running n number of registries, and then I have capacity for running Redis, and I'm having to manage all of this stuff. ECR, on the other hand, I just point at it and it works, and it scales perfectly in the back end. I never have to think about it. It's just there, always available. It also encrypts at rest using KSM, and it compresses my images for me. So I don't have to worry about I still worry about how big the image is, but the only thing that I pay for with the ECR is how much space I'm taking up. And because it's compressing, if I did happen to push a big image, that's okay. It'll compress it down if it's compressible. So I get to take advantage of that as well. The way that instances interact with a Docker registry is by logging into them. And so we built a command, ECR get login, that would actually get a proper Docker login command. So this is really step one for you using ECR, is to simply log into it. So run this command, get the output, and then paste it into your terminal, and you'll be logged into ECR. So Kubernetes. How many of you guys run Kubernetes? Not as many hands as I expected. So I shouldn't ask, but I'm curious. Does anyone run Kubernetes in production? What? OpenShift. All right, we'll count that. So we launched Kubernetes GA in, I believe, June. Before that, we were looking around. Actually, CNCF did a survey, but we were internally trying to figure out, we were talking to customers that were asking us about Kubernetes, and we started noticing a lot of customers are running Kubernetes on AWS. Now, they could run Kubernetes elsewhere, or they could choose to manage it themselves and launch it on EC2 instances and run their own control plane on AWS. And then this CNCF survey came out, and we see that 57% of Kubernetes workloads are running on AWS before we actually launched a managed service. And so we announced last year that we were going to come out with a managed service, and then it went GA, I believe, June or maybe early July of this year. So again, a make it easier for us type moment, right? We saw that customers were struggling to run Kubernetes, manage the control plane, deal with upgrades, deal with etcd outages, and all that stuff. And we said, you know what, if we put a team of experts on this, we could probably do this at scale for all of our customers. So that's what we did. And then we want to add native AWS integrations. So on top of Kubernetes, it would be really nice if we could, just like we do for ECS, try and integrate in as many other AWS services as possible to make that a seamless experience. So there's two approaches when you want to do something like that. One approach is to fork the upstream project and then maintain your own version of it. And that's a fine approach, but that's not what we wanted to do. We understood that the Kubernetes community values openness and values, upstream contribution. And so instead of doing that, we want to provide the absolute vanilla upstream version of Kubernetes. So it is pure Kubernetes, unmodified, upstream version, and then anything that we want to add on, we actually work upstream with the community to get it added. So that is Amazon EKS, Elastic Container Service for Kubernetes. It is certified by the CNCF, so they've taken a look at it, taken a look at our setup, and they've said, yes, this is pure vanilla upstream Kubernetes, unmodified, etc. So it has our seal of approval. Excuse me. It is, again, managed upstream service. It does have some native integrations into AWS. There's a deep dive on EKS coming up later today. You'll get to see some of that. And then we have a lot of projects where we are contributing back to the community. If you've ever paid attention to the Kubernetes community, they're divided up into SIGs, special interest groups. And the AWS SIG is a very active group that is now operated by us, but has a lot of contributions that we've brought so far in a pretty short amount of time. So we've launched, for example, ALB integration. So now as a 1.0, you can have your ingress controller be an ALB rather than a whole bunch of ELBs. Prior to that, it was ELBs, and our customers were, they'd start out, it was fine, everything was working, but then they started noticing, you know what, I have like 20 or 30 ELBs, and they all have a certain fee per month or per however long they're up. So ELB is actually a pretty substantial portion of my bill now. And we said, well, ALB is more scalable, and you would just need one of those. So we started working on integrating ALB. So that's a great example of contributing back to the community. And the community gets then to take advantage of that. If they're using EKS, they can take advantage of the ALB ingress controller. Or if they're running their own control plane, no big deal, they still get to take advantage of the ALB ingress controller. So the way it works, if you've ever used Kubernetes or you have ever seen someone use Kubernetes, you've almost certainly seen the kube control command. So someone at their laptop is running kube control. They're issuing commands to an API process that's running on the control plane. So this API process on the control plane, normally, if you're running the control plane, is just a container running on a fleet of hopefully highly available control plane servers. In our case, on the other hand, we're running those for you, so that's why we have a little cloud icon. You don't have to worry about running those or managing that. You just issue kube control commands, and it talks to the API on our control plane. And then we will issue instructions, and any worker nodes that you have that are registered to that control plane will start to act on those instructions and start to spin up servers, or containers, I should say. So EKS workers, these are the instances that you bring, that you attach to the control plane. And then the control plane itself is just mycluster.eks.amazonaws.com. So it's just a control plane that we're operating for you. We offer semantic versioning of EKS. So unlike ECS, where there is no version, because there are releases of Kubernetes in a versioned manner, we want to make sure that we have that same feature. So we release versions of Kubernetes as they come out, and then you're able to upgrade to them. By the way, I believe we demoed at reInvent the upgrade process, and that should be rolling out very, very soon for you to upgrade your clusters from 110.11 to 111, I forget the patch number. So you'll be able to very easily, just in a drop-down box, pick the next version and upgrade your cluster. I don't know if you've ever, raise your hand if you've ever upgraded a Kubernetes cluster that you were running. How long did it take you? 20 minutes? Wow, that's impressive. I was expecting all day. It's not an easy process. And in fact, for a while, the process was actually go build another cluster and cut traffic, deploy all your applications and cut traffic over to it. So it's been a very grueling process to deal with, and our customers don't like having to do it. So just having a drop down and picking the next version makes it trivially easy. So Kubernetes upgrade will come out. We will automatically apply patch updates for you. So you don't have to do anything for those. Those will just, you'll get them. And then for the minor version updates, the ones that include new features, that'll be where you take action and you decide which clusters to upgrade and which maybe you don't want to upgrade. So what does that leave for managing? It leaves managing workers, right? So we're managing the control plane for you now. That leaves the data plane. By the way, all day long, you're probably going to hear me refer to control plane, data plane. We think just about everything at AWS, that's how we think about it. We think about it in terms of the management of the service and then the execution of what the service is trying to do. So in the Kubernetes realm, the control plane is the scheduler, the thing that the cluster orchestrator, the API service. That's all control plane processes. And then they come up with a set of instructions that they're going to apply to the worker nodes. And the worker nodes are just where your containers are going to execute. So your containers launch out onto the data plane. So we hear from customers, you know what? I don't want to worry about even managing the data plane. So we came out with Fargate. Fargate is a managed data plane. So just like we manage 2 control planes for you, you get a choice. You get the control plane for ECS or you get the control plane for EKS. We actually now offer you a data plane management service called Fargate. And right now, Fargate's available for ECS integration, and we hope sometime in 2019 to make it available for Kubernetes as well. And you should see, again, in the AWS SIG, you should see work toward in that direction, hopefully very soon. So no cluster, no infrastructure to manage, no instances. This is as close to serverless as you can think of. No servers to patch, upgrade, update, worry about the sizing of, etc. I said most of this already. So the goal is just give it a task definition, say run my container. And Fargate will, the control plane will take that definition and launch it out onto a set of infrastructure, and you never have to worry about, do I have enough capacity? So this allows you to focus more on the workload, less on making it run. The idea is to shift your focus up the stack, keep shifting it up so that you can worry about less and less and less of the dependencies and more about the business logic. We're always driving towards doing the commodity work for you, doing the utility work for you so that you can do the thing that makes your company unique. So how does this look in practice? Well, used to, before we launched Fargate, a cluster would have this line, and you would see that there are 2 services, 2 running tasks, 2 pending tasks, and you keep going, and you see your CPU and memory aggregate utilization for all your instances, and that you have 2 container instances. Well, on Fargate, we added a second line, and you can still see services running task, pending task, but there are no instances. Now, the thing that it doesn't call out in the slide is every cluster is a Fargate cluster automatically. Every cluster is a heterogeneous cluster. So you can launch tasks onto instances, or you can launch tasks as Fargate tasks, all in the same cluster, the same isolation boundary. You have a very wide variety of combinations of container sizing you can pick, down to a quarter CPU. So I don't know if you know this, but Docker allows you to run with fractional CPUs. So we'll go all the way down to a quarter CPU and half a gig of RAM, or all the way up to 4 CPUs and 30 gigs of RAM. I just gave this talk 2 days ago, and I said to the audience, I've never met anyone that actually needs 30 gigs of RAM for their container. And someone came up to me after and they said, I'm embarrassed to say, but we use 30 gigs of RAM for our container. And they were actually running Fargate tasks. So they were running batch workloads that were doing, a high amount of processing, large amounts of data, and they needed a bunch of in-memory calculation space. So it makes sense. It was just something that I was shocked to find out about. The cool thing is, though, you pay for what you use, what you provision, not for what you have to have running. And the reason that customer on Monday told me that they switched to Fargate is because before Fargate, they had to have very large instances running all the time, because when work would come in and get dropped into their queue, they would have to launch the container and process the job. Today, they still have that same way of working, but they don't have to have large instances running to launch the container onto. So they aren't paying for the capacity unless they're using it. And so they were actually able to cut their bill because they launch a Fargate task, it processes everything necessary, and then that container dies, and they stop paying for it. They don't have to have that capacity all the time. And then they can also horizontally scale, so every time a task comes in, a container gets launched, and then when it's done, it dies, versus having to have a queuing system in place before. When they were running instances, they would launch as many as they had capacity for, and then they would have to sit there and wait to process the next job until one of the containers was finished and died. So this is changing compute. I hope that there's something that I've said right now that you can identify with. We should maybe think about changing that. Whether it's being able to fan out horizontally infinitely, or being able to have containers that are huge at your disposal without having to pay for the hot capacity just to keep around unused. These are all things that we're hoping you can start to think about, start to evolve your stack, and hopefully improve your situation. Really, the movement is to treat the container as the new compute primitive. So instead of thinking about EC2, think about as EC2 was growing up as a service, we were adding features to it, making it better. Now we're doing that for containers. So over time, you've seen us add ENI networking to it, add IAM roles to it, add security group definitions. So now you can define for your container or for your task, it's going to get a custom ENI attached to it. It's going to get a security group built for it. It's going to get an IAM role attached directly to it. So you don't have to think about those things in terms of the underlying EC2 instance anymore. You just attach them to your container. So we're continuing to evolve that and continuing to enhance the container experience. It's becoming the new compute primitive. Auto-scaling, I left out. So that list of things that we've enhanced. Now you can auto-scale the task rather than auto-scale instance by instance. So these are all things that we're evolving the container, evolving the task to be the new compute primitive. What does this allow you to do? Focus on running your application. Focus on the higher level, the business logic, the stuff that you are good at, that your company is around for, that makes you different from your competitor. And leave the utility stuff, the commodity stuff, to us. So, quick summary, and then I'll get you out for a break. This is the container landscape for AWS. We have ECS, EKS for control plane, and then for data plane, we have Fargate for ECS, and coming hopefully soon in 2019, Fargate for EKS. ECS is a managed first-party platform, so it has deep integration into other AWS services, and you can launch your containers. There's really no end to how big it can scale. EKS is a more open source experience. So if you are running in multiple locations, perhaps in your own data center, and you want the same experience everywhere, including outside of AWS, then this is a good choice for you. It gives you that open source experience everywhere you operate. Fargate, managed data plane, no end to the amount of scaling you have available to you, and you can scale up and scale down as needed, second by second, and add capacity or remove capacity without worrying about having the underlying instances available. If you need help figuring out what option is best for you, my coworker Nathan Peck wrote a blog article. Here's a link. You'll get the slides, by the way, so you'll have this in the slide deck. There's more links available to you for getting started. Getting started with EKS, getting started with Fargate. We have blogs. Here's the Nathan Peck article. And then the GM of the container organization actually has a presentation that he did at reInvent, the State of the Union. So definitely check these things out. And with that, hopefully you now know everything there is to know about containers on AWS. So the rest of the day, we're going to spend kind of diving a little bit deeper into each of these areas that we talked about. And please come back for the parts that interest you. But until then, we have a break until, I believe, 11:30. So see you around. I'll be up front if you have any questions that you want to ask.